All right, let's dive into a problem that so many of us have run into. We're going to talk about that weird, annoying hum or buzz you sometimes get in your electronics, the one that seems to show up out of nowhere. We are going to get to the bottom of it, and you'll see there's a surprisingly simple fix. You know exactly what I'm talking about, right? You're just chilling, listening to some music, and all of a sudden your speakers start buzzing like crazy. Or maybe when you key up your radio, the lights in your house do a little flicker dance. It's super common, super frustrating, but what is actually going on? Well, the culprit is this invisible force that's all around us. It's called RFI, which stands for radio frequency interference. Now, that sounds pretty technical, I know, but don't worry. We're going to break down exactly what that means and, more importantly, how you can stop it. So let's start by pulling back the curtain on this whole mystery. What in the world is radio frequency interference, and where is it even coming from? To put it simply, RFI is just unwanted noise that a radio signal blasts into a nearby electronic device. You can kind of think of it like your radio signal is accidentally shouting at your computer speakers, or maybe your neighbor's TV, and that's what's causing all that frustrating static and buzzing.
Okay, so this is where things get really interesting. In a ton of cases, the source of all this interference isn't some random thing out there. It's actually coming from your very own antenna system. Let's unmask the real culprit here.
And here it is. The big problem is that the coaxial cable that connects to your antenna, your feed line, isn't just carrying a signal, it's actually broadcasting one itself. It's basically turned into a second, accidental antenna that you never wanted. Now, the nerdy term for this whole mess is common mode currents. These are basically stray signals that have managed to escape. Instead of staying tucked away inside the cable where they're supposed to be, they start traveling all along the outside of the cable's metal shield. You know, the source material we're looking at just nails it. It says that when these currents flow on the outside, the entire coax cable, all the way from your antenna back to your radio, becomes an active radiator. And here's the kicker. Your whole setup is now just polluting your space with stray radio signals. That's why your speakers are buzzing and your lights are flickering. The call is coming from inside the house. It's starting right there with your own antenna setup.
But don't you worry, because there is a brilliantly simple and super effective fix for all of this. So let's introduce the hero of our story, this little device called a choke.
Yup, the solution is something called a common mode choke. You might also hear people call it a current ball-in or maybe a line isolator. But honestly, whatever you call it, its job is dead simple: to stop those stray signals right in their tracks. The best way to think of a choke is like a bouncer at a really exclusive club. It stands on the outside of your coax shield and basically tells those stray signals, no, you're not on the list. You can't come in here. But at the same time, it lets your good, clean, desired signal pass right on through the inside of the cable, totally untouched. It's a perfect little gatekeeper. Okay, but knowing you need a choke is only half the battle. Knowing where to actually put the thing, well, that's everything. Placement is absolutely critical, and it changes depending on your antenna. So let's break out our field guide. First up to bat, the EndFed antenna. Now, these are famous or maybe infamous for causing RFI, and that's because by their very design, they use their feed line as part of the antenna system itself. It's something called a counterpoise, which acts like the other half of the antenna. So for an EndFed, you've got two main choices. If you're using a separate wire as your counterpoise, you put the choke right where the cable connects to the antenna. Easy. But if you're not using a separate wire, then you let the first 2 to 4 meters of your coax cable act as the counterpoise, and you put the choke after that section. This basically traps the radiation in that small part of the cable. All right, next up, we have the vertical antenna. It works on a pretty similar idea as the EndFed, but where you put the choke depends on the specific type of vertical you're working with. This is actually pretty straightforward. For a classic quarter-wave vertical, the kind that uses those ground wires called radials, you'll want to stick the choke as close as you can to the feed point. That stops the coax shield from acting like another unwanted radial. Now, for the longer half-wave and 5/8 wave verticals, which don't need radials, you just treat them exactly like the EndFed antenna we just talked about. Now, you might be thinking, aha, I've got a perfectly balanced dipole antenna, so I must be immune to this problem. Well, not so fast. When you feed a nice, symmetrical dipole with an asymmetrical coax cable, you create an imbalance. And that imbalance leads to, yep, you guessed it, common mode currents.
The good news is, the fix for a dipole is the easiest one of all.
You just put a common mode choke right at the feed point. For a dipole, this choke is often called a one-to-one balun, which is just a fancy name for a device that helps connect a balanced antenna to an unbalanced cable. That's it. Problem solved.
So let's do a quick recap of where to put this thing. For most antennas, we're talking the dipole, the quarter wave vertical, and an EndFed that has its own counterpoise. The rule is super simple. Put the choke right at the feed point. The only real exception is that EndFed that uses its own coax as the counterpoise. For that one, the choke goes after the first few meters of cable.
Okay, so as we start to wrap this up, what's the one single most important thing to take away from all this? It really boils down to one simple but really powerful idea. The core idea, just like our source material says, is to tackle the problem at the source. So instead of running around trying to shield all your speakers or putting filters on all your power lines, just go straight to the root cause, your antenna system. Adding one simple choke is almost always going to be the most effective and cheapest way to solve the problem.
You know, this whole thing really makes you think, doesn't it? We have this invisible, complicated-sounding problem like RFI, but it turns out to have such a simple, elegant solution once you understand where it's coming from. So that leaves me with a final question for you. What other invisible problems out there might have surprisingly simple solutions if we just know where to look?